Hey y'all, we just found the weighted OLS fit and the inverted weighted OLS fit. We're going to use these two together to find the GMR fit. And this is going to be, here I clicked over to my new sheet labeled GMR fit. The GMR fit is going to be the fit that we use to find what P is. For our weighted OLS and for our inverted weighted OLS, we didn't bother finding B because we don't need it and because we don't really care about the lines produced by weighted OLS and inverted weighted OLS. All we care about is the slope that's produced because these slopes are what we need to calculate the GMR fit. So we'll get our GMR fit and then we can use the GMR fit slope and our average x and average y to find B. So, clicking onto the GMR fit sheet. All right, so we're going to want to get our slopes in here so we can have our weighted OLS make sure it all fits in these cells. And now we'll have our GMR. And this is going to be M and sigma M. Now I'm titling this M. When I copy over from summary and fits, I'm copying over this one, which is labeled 1 over M. It's just what we're going to use. So let's copy these over, and we're copying them over by reference. And I'm going to make a note on that at the end, actually. So we'll have equals our weighted OLS. It's this one. And our sigma is right here. Now our inverted, this is a 1 over M. Just this one. And now equals uncertainty. Yeah, okay, let's talk about it now. The reason why it's good to reference all these by cell is because you might have noticed that this value changed like 3 times when I was copying over data. And that's because these data all hinge on these data for our ln with the included sigmas that are calculated with these 2 big sheets of Monte Carlo, with these referenced. So ultimately the point is we take our GMR fit and we find the slope. If we find that that slope jumps around a lot, it's because we don't have enough MC trials. So all we'd have to do in that case is stretch our trials down. Around here, yeah. We have 1,000 trials now. We could stretch to 2,000, 3,000, and all we would need to update would be in here. We'd need to change the last, the end of the range. But our summary and fits table and our Linus estimates all hinge on these cells and not exactly these values. So if we update these cells with more trials, we don't need to change anything else. So if we find that our GMR slope is jumping around or is fluctuating, more specifically, too much, we can increase our trials. But we don't have to mess with this sheet at all once we put it together because they're just based on these references, which are just based on these data, which are exactly the data from our ln LMC and ln TMC sheets. They're referenced individually. So if we find that our data is being weird and fluctuating, it's because our Monte Carlos aren't long enough, and we can update them so that they are long enough. But we'll see when we get there. So our GMR M and sigma M will come out from our Monte Carlo. So let's get our Monte Carlo together. Do trial, and now This is our MC. Because we're going to do a BMC too, but let's do them one at a time. MC for Monte Carlo, of course. Great, so trial 1 and then trial 2 is 1 equals 1 plus trial 1, which is 1, and then we get 2, which is cool. For our MMC, remember that we're taking the square root of our weighted OLS divided by our inverted weighted OLS. And we're doing it in MC, so we're going to use norm inverse, and we're going to use their sigmas. So our first one is going to be weighted OLS. So we write that as norm inverse rand, because we're taking a random choice, and the distribution is defined by these one and this one. And there's our norm inverse, and then we're going to divide it by the other norm inverse. Rand, and we want this one. Oops, we weren't done. Oh, I put a period, that's why. All right. Sorry. Now we're still defining our inverted weighted OLS distribution. Comma, not period. Great. And then close. To finish this off, we need to make sure that these don't change when we change the rows. So we have to put a $ in front of every number. Awesome. Get this down one more. And now we can pull down from trial 2 all the way down to the bottom of the sheet. We're going to have to add 1,000 more so that we can bring this all the way to 1,000 trials. Only get to 994, so we have to add. Let's just add. We added 1,000 before. Let's add 10. That's weird. Okay, so I pulled the formula for the GMR down all the way, but I'm getting some errors that we're going to need to reconcile. So let's shoot back up to the top and let's see what's going on. So our error exists because our function is a square root of M1 divided by M2, with M2 being the inverted. But because our sigmas are so close to the value of M, we're pulling from a normal distribution, so something like 68% of the time we're within one standard deviation, but the rest of the time, the 32%, or more specifically, the lower end of the 32%, so that's 16% of the time, it looks like we're going to get a negative number for our norm inverse taken from here. And that's bad. We definitely don't want a negative number, because when we do, we're going to get this error. So to reconcile this, I'm going to put out in the front of all this stuff just ABS. That's absolute value. Add a parenthesis there and one at the end. And then we come out, it's a number that looks like all our other numbers, but now it has to be positive. So let's pull this all the way down. Hopefully we lose our errors. Just do 1,000. Awesome. Looking like we don't have any of those capital NUM errors. So that's good. Good. So, you know the general GMR is M1 divided by M2, where M2 is inverted. But for this one, we're doing a special case. We have to have this absolute value in the front. Oops. This absolute value in the front, so that we make sure we're not taking the root of negative number. Let's get the average of standard deviation. Now, then we'll have our average and standard deviation on the slope that really is our slope for this lab. So we'll do equals average. I'll just start it. I know this goes to 1006. So type it in, we're all set. And this one will be the standard deviation. So this will be equals st dev.s, start it, and then awesome. So we have our standard deviation and we have our GMR slope. There's one more thing to find, and that's going to be B and sigma B, because the point is we want to be able to produce some data that we can throw into Plotly, and we can look at our GMR line. So we know the slope for our GMR line, but we need to know what B is. So we're going to have to do a whole nother Monte Carlo for it. We'll call it BMC. And to do this, we're going to need our average X and average Y. So let's grab those and put them over here. They're in our summary table. Let's put a little table spot so we know where we're putting them. Average X. Average Y. Great. Now let's grab them. Oops. We have to reference. Remember, if anything updates, our average X and average Y might update. So let's just reference our average X and our average Y. Great. We're on the BMC. We know the formula for B is Y minus MX. So to have our variation in this, we're going to use this one as our M. And we see that our OLS M and our inverse weighted OLS M are both positive. So we know that our GMR is positive. So we don't need to correct sign. So let's have equals average Y minus M times average X. Now, average X and average Y, I don't want to change, so I'm going to increment them on the number. But I do want B7 to change. We're going to find B for each of these individual M's. And then we can take an average and a standard deviation. And we'll come out with B and an uncertainty on B. So instead of using any norm inverse things here, we're just going to use each respective slope, because each respective slope is pulling from the normal distribution. So this is how we're going to do it. This is our formula. Bang, enter. Oops. Why are you mad? I don't need. I put an ampersand on accident. Gotta be a $sign. All right. Now I can pull this. All the way down to 1,000, awesome. And it looks like we're not getting any errors, which is good. So now we want, for the GMR fit, because we're right, we're going to put B and sigma B here. So we want equals average D7 to D1006. That's it. That's what we want. That's awesome. Suggested to us. And now we want equals deviation. And this is going to be the same range. We go to D 1006. Awesome. So now we have B and sigma B, and we have M and sigma M. We can use these with our X data points to come out with Y data points that we can then graph in Plotly to graph this line. We did that in the last lab, so I know you're all familiar with it. And So, in conclusion, with 2 Monte Carlo simulations, we found what our GMR M and its uncertainty is, and our GMR B and its uncertainty. So there it is, and that concludes this video.